Hello and welcome to another yearly past paper session. This paper is again an S2 exam from 2023. The variant is 6.2. Let's start solving. It says a random variable x has the Poisson distribution. This use a normal approximation to the Poisson distribution to find probability of x greater than 30. Okay, so lambda is equals to 25, which means that the mean is 25 and the variance is also 25, but I still have to do a continuity correction. So I'm going to say that this becomes x is greater than 30.5. You convert this to z. Let's see what number we get. 30.5 minus 25 divided by 5. That gives me 1.1. So probability of z greater than 1.1. 1 minus 5, 1.1. What is 5 of 1.1? Let's look at our table. It's 0.8643. So it's 1 minus 0.8643. That's 0.1357. So 136, if that is the correct answer. Yes, that is indeed the correct answer. So approximately equals to 0.136. Then says the random variable y has a Poisson has the binomial distribution. So this is n, this is p, where p is less than 0.05. Okay, so p is small, so therefore you convert it to a Poisson distribution. Use the Poisson distribution to find the probability to write down an expression in terms of p for probability of y is less than 3. Okay, so you need the lambda. Lambda is in this case np, so 100 into 0.05, which gives me 5. No, sorry, 100 into p, which gives me 100p. The probability of y less than 3 is probability of 0, 1, and 2. So e power minus lambda plus lambda e power minus lambda plus e power minus lambda into lambda power 2 over 2 factorial. So that is the expression in terms of p. You could simplify this and write this as one fraction as well, one line expression as well. Okay, the length in minutes of a mathematics lecture at a certain college is mean mu and standard deviation 8.3. The total length of a sample of 85 lectures was 4590 minutes. Calculate a 90% confidence interval for mu. So confidence interval for mu is x bar minus z value into sigma over root n. Okay, and x bar plus z value into sigma over root n. So x bar is 4590 divided by 85. What is the z value? Z value for 95%. So I'm going to read 97.5 from my table, which is 1.960. So I get 1.960 into 8.3 divided by root of 85 mu 4590 over 85 plus 1.960 into 8.3 over root of 85. Okay, let's see if we get the correct answers. I'm going to type this on the calculator directly. Just change the sign. That's 52.2, correct to three significant figures. And that one is 55.8, correct to three significant figures. Simple question so far. Let's look at the next one. It says the length in minutes of history lectures at the college has mean m, and the standard deviation s using a random sample of 100 history lectures. Okay, a 95% confidence interval was m. where M was found to be to have width 2.8 centimeter, 2.8 minutes. Find the value of it. So width is basically 2 times z value into sigma over root n. Okay, so 2 times 1.96 into s over root 100 is found to be 2.8 minutes. So I solve for s, 2.8 into 10 divided by 1.96 divided by 2. So s comes out as 50 over 7. So like if that's the correct answer, yes, that is indeed the correct answer. Then it says the researcher read a magazine article which stated that boys aged 1 to 3 prefer green to orange. It claimed that when offered a green cube and an orange cube to play with, the boy is okay. So researchers read a magazine article which stated that boys aged 1 to 3 prefer green to orange. It claimed that when offered a green cube and an orange cube to play with, the boy is more likely to choose the green one. The researcher disagrees with the claim. She believes that the boys of this age are equally likely to choose either color. In order to test her belief, the researcher carried out a hypothesis test. At the 5% significance level, she offered a green cube and an orange cube to each of 10 randomly chosen boys aged 1 to 3 and recorded the number of boys who agreed to the who choose the green cube. Out of the 10 boys, 8 boys chose the green cube. So this is my test statistic. Okay. Assuming that the researcher's belief that the either color of the cube is equally likely to be chosen is valid, a student correctly calculates that probability of x equals to 8 is equals to 0.0439, correct to three significant figures. He says that because of this value is less than 0.05, the null hypothesis should be rejected. Explain why this statement is incorrect. So in order to test this claim, I should calculate the probability of x greater than or equals to 8 should be calculated, not just 8, because the alternate hypothesis is that the probability is greater than 0.5 should be calculated. Okay, so your decision about your probability is basically dependent on the sign of the alternate hypothesis. We're going to discuss, see that in the next question. Let's just carry out the test. So the researcher is hypothesizing that it's zero point 0.5. Someone else is hypothesizing that it's greater than zero point 0.5. People who choose the green cube. Okay. So how many chose the green cube? 8 chose the green cube. So I'm going to calculate the probability of x is greater than or equals to 8. That means I want 8, 9, and 10. So I'm going to write 10C8. Both are zero point 0.5 plus 10C9 and 10C10. Okay. So that's 7 over 128, which in decimals should give me 0.0547. Okay. So 5.47 is greater than the confidence interval. Okay. Sorry, significance level is greater than the significance level. Fail to reject H naught. H naught. The researchers claim cannot be rejected. Okay, so the magazine may have been incorrect. Okay, let's see what the there's evidence there's there is insufficient evidence to accept the hypothesis that boys prefer green. So you could write that, or there is sufficient evidence um, to accept the researcher's claim. Okay, another researcher claims that a type 1 error was made. Explain why this cannot be true. Type 1 error is made when null hypothesis is rejected. Hmm. Okay. Then says a similar test at the 5% significance level was carried out later using 10 other randomly chosen boys, aged 1 to 3. Find the probability of a type 1 error. Okay, so a type 1 error is the true significance level. Okay, so at 8, I wasn't getting this probability. Let's check at 9. What is my probability? So I'm going to calculate the probability of 9 and 10. Okay, so that the probability becomes smaller. It was 5.47% before. I want the probability to be smaller. 10C 9.5 power 1, zero point 0.5 power 9, 10C 10, zero point 0.5 power 0, zero point 0.5 power 10. Okay, so I think 11.5 power 10. So this is coming out as 0.0107. That's 1.07%. That's the probability of a type 1 error in this case. Yeah, okay. So that's the correct answer. Okay, moving on. This is question number 4. It says the height h in meters of a certain type of tree is normally distributed with standard deviation 0.67. In order to test whether the mean population mean of h is greater than 4.23, the heights of a random sample of 200 Ts were measured. Okay, write down suitable and null and alternate hypothesis. So h naught is that mu is equals to 4.23, and h1 is mu is greater than 4.23. The sample mean h dash meters of h bar meters of 200 degrees is found and the test is carried out. The result of the test is to reject the null hypothesis at the 5% significance level. So it's a upper tail test. What I want to calculate is the border, the start of the rejection region. So I'm going to say that I'm going to calculate the probability here. What's 95%? Let's check. 95% is 1.645. So I'm going to write 1.645. This is a z value. So I'm going to convert the z value into a value for h bar by using my mean and standard deviation that I've been given. What is the standard deviation? It says 0.67. So 0.67 divided by root of 200. Let's see if we get the right answer. I'm getting h bar as 4.307. 308. I would rather write 31. H bar is 4.31. So what are the set of possible values of x, z? So h bar is greater than 4.31 for rejecting the null hypothesis. Okay, so greater than or equals to 4.31 or greater than 4.31 is both the same thing. Ajit said that in B we would assume that h bar is normally distributed, so that it was necessary to use the central limit theorem. Um, it says already that there's a normal distribution involved, so I don't need the central limit theorem. I need the central limit theorem when um, it is not normally distributed. No, I don't agree with Ajit, because heights are already normally distributed. Normal. Okay. The random variable x has the probability density function f given by this, where a and b are positive consonants. It is given that expectation of x. The expectation of x is x f of x. Okay, and it says that this is ln2. So that b equals to 2a. Okay, so I integrate on the entire limit, and I integrate what? X over 1 over x squared. So 1 over x integrated becomes ln x equals to ln2, ln x with limits. So ln b minus ln a equals to ln2, applying the rules for logarithms. So the ln's get equated, so b equals to 2a. I think that's simple. Show that a equals to half. Okay, so A equals to half. So I know that if I integrate this entire thing 1 over x squared from a to b, it should become 1. So this becomes x power minus 2 plus 1 over minus 1 from a to b is 1. So minus 1 over x from a to b is 1. Minus 1 over b minus minus 1 over a equals to 1. B equals to 2a. That's from the previous part. Okay, that's from the previous part. Show that b equals to 2a. So 2a plus 1 over a equals to 1. I take a common denominator 2a minus 1 plus 2 equals to 1. So 1 equals to 2a and a equals to half. So a is equals to half and then b should equal half into 2, which is 1. So for the median, I'm going to say that I want to integrate from 0.5 to m, 1 over x squared, and I want a probability of 0.5. So x power minus 2 plus 1 over minus 1. This is a simple question, I think. Minus 1 over x. This is basically half, if you're getting confused. It's the value for a. It was going from a to b, right? The function was from a to b. Two. So 1.5 equals to 1 over m equals to 1 over 1.5, which is 2 over 3. I hope I've done it correctly. Okay, so a factory makes loaves of bread in batches. One batch of loaf contains X kilograms of dried yeast and Y kilograms of flour, where X and Y are independent normal distributions. Dried yeast costs this and this, and flour costs that. For making one batch of bread, the total cost of all other costs is 55. The factory sells each batch of bread for $200. Find the probability that a profit on one randomly chosen bread is greater than 40. Okay, so what I'm trying to do here is to calculate a profit function first. What is my profit made up of? I sell one bread, so one batch, so it gives me a revenue of $200, and then I start subtracting the cost. There's 55 other costs, and then there's a cost of yeast, which is X, and flour, which is Y. So I get 145 minus 113.5x minus 0.9y. Now, what is the mean of this profit? Now, whenever something is added or subtracted from the mean, it's so 145 is going to be part of the mean profit as well. And then I'm going to subtract the mean of x times 13.5 and the mean of y times 0.9. So I'm going to end up with my mean profit. What is my mean profit? That if average values are considered, how much profit do I make? I make a profit of 45.55. Okay, I think that should be uh, what I'm looking at. Yeah, I think that should work. Then the variance of profit. So constants don't affect the variance, okay? But subtraction also doesn't affect the variance. So 13.5 squared times 0.02 squared plus 0.9 squared times 3 squared. Okay, 3 squared and 2.02 squared were there in the question. 13 point because these are multiples, so 13.5 has been squared plus zero point 0.9 squared times 9, 7.3629. Okay, yeah. So I just want to check if my profit is greater than 40. So the probability of z greater than 40 minus 45.55 divided by root of 7.3629. Probability of z greater than minus 2.045. So 1 minus phi of 2.045 minus 2.045. So 1 minus 1 minus phi of 2.045. That gives me phi of 2.045. Let's do that from the table quickly. 2.045. 0.9795. Yep, that is the correct answer. Let's see if this has a second part to it. No, it doesn't. I take you to the last question then. A random variable x has the Poisson distribution 2.4. I just want to find the probabilities of 2 and 3. So I think that's simple. Plus e power minus 2.4 into 2.4 cubed over 3 factorial. Okay, so 470. Okay, let's check if that is the right answer. Took me a while to calculate. Then there's two independent values of x are chosen. Find the probability that both of these values are greater than 1. The probability of x greater than 1 multiplied by probability of x greater than 1. Okay, both are the same distribution. So I'm going to say this is 1 minus probability of 0 and probability of 1. And this is also the same, 1 minus probability of 0 multiplied by probability of 1. Um, So two independent, you could do this with binomial and say this is n2 and this is what my success is, and then calculate the probability of two successes. Okay, so 1 minus e power minus 2.4 minus 2.4 e power minus 2.4. 0.6916 and 0.6916. So that squared gives me 0.478. Yes, that is also the correct answer. Let's look at the last part. It says that is given that r and r plus 1, find the possible values of r. So e power minus 2.4 into 2.4 power r over r factorial is less than e power minus 2.4 into 2.4 power r plus 1 over r plus 1 factorial. So this cancels out, and I could bring r plus 1 factorial here and r factorial here. Now, a lot of students don't know how to open up a factorial, but this is something that has come up very often now in S2. So you need to know. Okay, what you need to understand is that, let me first simplify the other side and then I'm going to demonstrate the factorial to you. So this becomes 2.4 r plus 1 minus r, so that's 2.4 on power 1 only. Now, when you write n factorial, it simply means n into n minus 1 into n minus 2, and you could stop at any point and write factorial after this. For example, 5 factorial can be written as 5 into 4 into 3 factorial at the end. Similarly, r plus 1 factorial will become a reduction by 1 in the next bracket. So I'm going to write r plus 1 and this is going to become r plus 1 minus 1, and I can put a factorial at the end. Why am I doing this? Because this will help me cancel out the denominator. This becomes r plus 1 into r factorial over r factorial. So r plus 1 is less than 2.4, r is therefore less than 1.4, so therefore r can be 0 or r can be 1. Okay, hence find the value of r for which probability of r is the greatest. So I'll have to find out either 0 or 1 is the greatest, or okay, no, I just want to find out the probability is the greatest. Okay, so what I am going to do is there is a limit. I will have to, okay. This question is then not about anything else. It's just about figuring out the mode. The greatest probability will come from, I don't know, this is working slower than usual. So when lambda is a decimal number, remember that the mode is the number just before this decimal number, so mod is therefore 2. Had lambda been a whole number, let's say lambda would have been 5, then I would have said that there are two modes, 4 and 5. Okay, so in this case the mode is 2, so the highest value of r is 2. R equals to 2 as the highest probability. Okay, that brings us to the end of the exam. I will see you with another recording in the next video. Thank you for watching.